The owner to this 31-day Waltham wall clock says it won't stay running anymore. At first sight, the pendulum looks like a heat compensating type. It's actually a decorative pendulum. The bars in the middle are non-functioning. The two weights are also decorative. They're hollow and light as a feather. This is a spring-driven clock. The weights are just for show. Remove these hands. The dial is held on with 3 Phillips-headed screws and is made from aluminum. Dial reads Waltham in large print. Down at the bottom in small print reads Korea. Looking at the pendulum again, the 3 sidebars have the standard vintage scroll stamped in them. They are aluminum with 2 brass knobs. The front of the bob is aluminum, finished with a clear finish. The finish has a slight yellow color to it, giving it a brass appearance. The front plate on the movement has a slight bend on 3 sides. These are a structural part of the plate and help hold it rigid under the stress of the mainsprings. These dots on the plate are from a patented German engineered process. The patent was presented in 1930 to the Johannes Clock Company. It helps with structural rigidity and strength, allowing for the use of thinner gauge materials. These Korean movements usually always have these spring deflectors on them. They deflect the spring away from the center of the movement to avoid contact with the second wheel pinion. Ribbed mainsprings are common on most Korean movements. They give an extra power boost and allow for a thinner mainspring to be used. Lubrication on the escape wheel and pallets is gummed up and dirty. Escape wheel pivot oil is gummed up. Looking at the mainspring pivots, condition of pivot hole and lubrication is in a sad state of affairs. It's mixed with dirt and brass and has turned to a slurry of tiny grinding particles. Wear in the brass plate is excessive. No wonder it stopped running. The other side is just as worn. There's a pile of crud next to each pivot. A lot of excess wear here. It's thick with brass particles. This second wheel pivot should have a bushing installed. Signs of clear residue and runs indicates the brass surface has been clear coated to protect it from oxidizing. Running the strike side to make sure all is operating as designed before it's taken apart. Listening for a steady rhythm, I can hear every 3rd or 4th strike, the train slows down. This indicates a problem with the meshing of the main wheel gear teeth and second wheel pinion. I'll listen to that a couple more times so I'm sure of what is happening. 1, 2, 3. Right there, it slows down. Right there, I can hear it slowing down. Time to disassemble. These spacers keep from making tool marks on the front plate and prevent from bending pivots. Strike side train first. Condition of the pivots look great. All these arbors have a black colored anti-corrosion finish on them. Mainspring arbors are made from a soft inner steel core with a hard chrome plating on the outside. These were used in the 1970s and proved to be difficult to polish or repivot. A lot of brass mixed with the lubrication. Exposing the pivot surface reveals the root cause of the brass mixed with the oil. The original pivot surface has lathe tooling grooves in it. The tooling grooves are in the soft steel core, and the chrome plating was applied over the rough surface. The Chime side pivot has the same condition. Lubrication here is black with dirt. I spoke to the owner on these pivots. They have decided to have me do a very light polish on them. It won't be enough to remove all the tool marks, but it will smooth them out a little. Over polishing these pivots can thin the chrome plating and break through to the soft inner core. I'll bush this Chime side mainspring pivot hole first. With this thin plate, it's quite worn. Mark the inside with color. This will help to see where the file is cutting easier. Now to file the unworn side of the egg-shaped hole until it's round and concentric. This centers the hole and helps keep things centered when cutting the hole to accept the bushing. My bushing material is slightly large for my watch lathe, so I'll start the making of the bushings on this larger lathe. Fitting the OD of the bushing to the plate. I've slightly polished the chromed pivot and just need to fit the new bushing to it now. I made the new bushing about twice the thickness of the original plate. In theory, it should last better than twice as long as the original setup. The original pivots lasted about 40 years, so these should last possibly 80 years. Mainspring bushings of this style are pressed in from the front of the plate. I always swage them over on the inside, so they are locked in. Swaging can be done with a convex punch or any convex surface. A nice polished ball bearing will work if no punch large enough can be found. It leaves a nice polished surface and at the same time work hardens the brass. Time to assemble and see how it runs out. The mainspring clamps were interfering with the second wheel pinions, so I tied them with wire. These thicker bushings are going to be a large improvement. Oil the movement. Pendulum leader assembly. The mainspring deflectors. One last look at the mainspring bushings. It's been running just great. Now the half-hour strike in slow motion. and the hour strike in slow motion. A nice Korean-made Waltham wall clock.